everyone. So today I thought I'd go through a couple questions from India, and these are from the 2018 JEE Advanced Paper 1 Mathematics section. So I thought I might put these in my senior AMC playlist because they're sort of a similar kind of difficulty. So pause the video here, see if you can figure them out. Okay, let's start with question 17. So the idea with these probability questions is that you want to have the number of ways that none of the remaining students gets the seat previously allotted to him divided by the total number of ways of seating the students. So that gives you the probability. Now we might start with working out the total number of ways of seating the students. So not necessarily fulfilling that condition. So that would just be 5 factorial. Now if you're new to combinatorics and you don't know what on earth I'm talking about, you would get that by thinking of it like there's 5 choices for who goes in the first seat, and then there's 4 remaining students to choose from for who goes in the next seat, and then there's 3 to choose from for the next seat, and then 2 choices, and then 1 choice. So we call that 5 factorial with an exclamation mark after it. So you can work out what that would be. That makes 120. So we're going to have like some number over 120, where this number is going to be the number of ways that the remaining students can be seated. Now, that's actually what we would call a derangement. So there is actually like a formula for working that out. Like there's various ways you can calculate it, but I'm not going to use that. I'm just going to do it using systematic listing, which just means, I want to write out all the different ways of doing it, but I want to do it in a particular order so that I can be sure that I haven't skipped any. So I would probably start with, let's go like seat 1, 2, 3, 4, 5. So student 1 has to sit in seat 1. Now we've got to sort of work out all the ways that these remaining students can be seated. So I can't put student 2 here because they're not allowed to have the seat previously allocated to them. So I'm going to start by putting student 3 in seat 2. And then I'm going to put student 2 here. And then I can't put 4 here, so I'm going to put 5 there. And then 4 is going to go there. Now, I've done that in that very specific way because I want to list them sort of in increasing numerical order. So I want to start with like the lowest possible number that I can put here, and then the lowest possible number I can put here, and so on. So that's going to be the first way to do it. Now let's think of the next way. So I can put 3 here again. Now I can't put this in a different order. Like I can't have 4, 5 because then they'd be in the same seats as before. So that's the only way to do it, going 1, 3, 2. So now I have to think about changing this number. So 4 would be the next lowest number that I could put there. And now we've got 5 and 2. I can't do 2, 5 because then the 5's going to be in the wrong column. So we have to do 5, 2. And then that's the only way to arrange them with 1, 3, 4 at the start. So now let's try the next one up from there would be 1, 3, 5. And that leaves 2 and 4, which have to go in that order because the 4 can't go there. Okay, and then there's nothing else that I could change this to. There's no higher number. So that's actually all of the ways of doing it with 1, 3 at the start. Now, we could actually kind of do a shortcut here because, so there's going to be like all the ways of doing it with 1, 4 at the start, and then all the ways of doing it with 1, 5 at the start. And because of a sort of symmetry of the situation, I actually know that there's going to be as many here as there are here, and as many here as there are here. So I could actually just do a shortcut here and say that there are 9 because there's going to be 3 there, 3 there, and 3 there. But I'll actually list them all out for you in case that was too much of a stretch of the imagination. So what's the first one we could put here? We could put 2 there, and then that leaves 3 and 5, which we have to put in that order. So the next one, I can't put 3 here, it'll have to be 5 there. And then we've got 2 and 3 left, so they could go in that order, or they could go in that order. And then that's all of the ones that have 1, 4 at the start. And then we can go 1, 5. I could put 2 there, and then 3, 4. Now we can't have 3 there, but we can have number 4 there. And then I can have 2, 3 in that order, or 3, 2. And then that's everything. That's all of them. And you can see I've listed them in increasing numerical order. Like if this was the number 13,254 and so on, think of them like that, then they're in increasing order. And that's sort of essential to systematic listing, because if you don't write them out in order, if you just sort of start listing them randomly, then you can never be sure that you've gotten every single one. But now we can be sure because I've listed them in order. So I know like there was nothing that could go between these two because of the way that I've listed them in a very organized way. So that's the idea with these kinds of questions. Okay, so we've got 9 different ways. So it's just, that's 9 ways out of 120. So we could simplify that fraction down because both those are divisible by 3. So we can make it 3 over 40. So that would be A. All right, let's do question 18. So first challenge in this one is just trying to work out what the question is asking. And for some of you who may not be so familiar with set notation, that might be particularly challenging. So I'm just going to delve into what on earth they're talking about here. So TI is the event that students SI and SI plus 1 do not sit adjacent. Let's think about what that means. So T1, for instance, would mean that the students S1 and S2 don't sit next to each other. And T2 is going to mean that students 2 and 3 don't sit next to each other. And T3 is going to mean that students 3 and 4 don't sit next to each other, and so on. Now, this little symbol here is set intersection. So you've probably seen, Venn diagrams before where you've got set A and set B, and then this bit in the middle is the intersection of the two sets. So you would express that as A intersection B. And that's as opposed to A union B, which means like the whole thing, the combination of the two sets. Now, if we're talking about events in probability, then you can think of this symbol as meaning and. Like it's saying that T1 happens and T2 happens, and T3 happens and T4 happens. So if we're talking about probability and you see this, think of that as and. That one would mean or. Okay, so what it's saying is that students 1 and 2 don't sit next to each other, and students 2 and 3 don't sit next to each other, and students 3 and 4 don't sit next to each other, and students 4 and 5 don't sit next to each other. So it's asking for the probability of that. So again, I'm just going to do systematic listing. I'm just going to write out all the different ways that that could happen. So like the previous one, it's going to be something over 120. So we just got to work out the number of ways that this can happen. So seats 1, 2, 3, 4, 5. What we could do is we could put student 1 there. And now I can't put student 2 here, because student 1 and 2 aren't allowed to sit next to each other. So I could put student 3 here. Again, I'm going to be listing them from sort of smallest numerical value to largest, so that I can be sure that I get every single one. So what's the next one that could go here? I can't put 2 there because 2 can't sit next to 3. And also I can't put 4 there because 3 can't sit next to 4. So let's put number 5 there. And then that leaves 2 and 4, so we can put them in that order. I actually can't put them the other way around because 5 can't sit next to 4. So that is the only way to do it with 1, 3 at the start. Because once we put 1 and 3 in there, we had to do 5, 2, 4. There was no other way to do that. So next I'm going to do 1, 4. So I could put 2 there, and then that leaves 3 and 5. I can't put 3 there because 2 and 3 can't sit next to each other. So I'm going to put 5, 3, and then that was the only thing I could put there, because 3 and 5 couldn't sit next to 4, so I'll have to change that. Let's go up to 5. Now if I put 2 there, then the only choices I have there are, like there's 3 and 4 left, and 3 and 4 can't sit next to each other. So I actually can't do 2 there. Let's try putting 3 there, and then that leaves 2 and 4. I can't do that either, because neither of those can sit next to the 3. So there's nothing I can put there, because I can't put 4 there either, because 5 and 4 can't sit next to each other. So that's actually all the ways we can do it with number 1 at the start. So I'll just draw a little line there to separate them. So let's try putting 2 at the start. Now we can't have 1 there, we can't have 3 there. I could put 4 there, and then we could have 1 there, and then 3, 5. Or I could do 2, 4, 1, 5, 3. Or what else can I do? I can't put 5 or 3 there, because they can't be next to 4. So that's all the ways of doing 2, 4 or something. But maybe we could try 2, 5. I could do 2, 5. I can't do 2, 5, 1, because that leaves 3 and 4, and they can't sit next to each other. But I could do 2, 5, 3, and then 1, 4. And then that's it for the ones that start with a 2. Now let's try 3 at the start. So I could do 3, 1, can't do 2 there, but maybe 4, and then that leaves 2, 5. Or I could do 3, 1, 5, 2, 4. And then, now I can't do 2 or 4 there, because they can't go next to the 3. But we could do 5, and then 1, what's left, 2 and 4. I could have 4, 2. I can't do 2, 4, because the 1 and the 2 can't go next to each other. Or we could have, 3, 5, 2, and then that leaves 1 and 4. I can't put the 1 there, but I can put the 4 there. Now, what you might notice at this point is that this one is what I would call a sort of a mirror image of this one. By mirror image, I mean, well, it's not really a mirror image, but it's what you would get replacing 1 with 5 and 2 with 4. Leave 3 as a 3. Sort of reversing the order of the numbers. Like if I took that one, replaced the 1 with 5 and the 5 with 1 and so on, I would get this one. And similarly with doing the mirror image of this one, that would give you that one. Now we could do a similar thing with each of these will have a mirror image. So like this one, for instance, would turn into 4, 1, 3, 5, 2. And you know, we know that that's going to be another possible way. So each one of these is going to have a mirror image, which is going to be something that I haven't listed before. So you could actually kind of stop when you reach this point. It's going to be these 7 ways and their mirror images. I'll just list them all out in case, you know, you bothered to list all of them out and you want to check against my ones. So this one's going to become 4, 2, 5, 1, 3. That one's going to be 4, 2, 5, 3, 1. That one's 5, 2, 4, 1, 3. And that one's going to be 5, 3, 1, 4, 2. So we get these 14 ways. So you might have done it by listing each of those out individually, or you might have sort of stopped there and thought, hey, I can double this. So either way, we're going to get 14 out of 120, and then we can simplify that down because both of those are even. So we get 7 out of 60. So that one is the answer. Alright guys, I hope you enjoyed this one. If there was anything that you didn't understand that you'd like me to clarify, then just leave a comment below. And if you'd like me to make more videos on JEE questions, then give this video a thumbs up and subscribe. And I'll put a link to where you can download these papers in the description. And if there's any particular question from the JEE or whatever other exam that you want me to go over, then just let me know in the comments.